Now in this video, we are going to take up one more case, the comparison of power transmitted by the hollow and solid shaft. So here, if you are considering the hollow shaft and the solid shaft of the same material, area of cross section and speed, because the power is generated with respect to speed. So what is that? The torsional stress of the hollow shaft, shear stress will be equal of the hollow shaft is equal to the shear stress of the solid shaft because of the material is same. So then area of the hollow shaft is equal to the area of the solid shaft, which is AH, will be equal to AS, and the speed is same. So the NH is equal to small ns, that is the speed of hollow shaft is equal to the speed of the solid shaft. As the what is the area of cross section of the hollow shaft? Area of the cross section of hollow shaft will be equal to area of cross section of the solid shaft, which is given, and then that is AH will be equal to AS. So what happens, which will be pi by 4 into d naught square minus di square will be equal to pi by 4 into d square. So d naught square minus di square will be equal to d square. Therefore, d naught square into, taking the common factor, d naught square into 1 minus di by d naught the whole square. So d naught square into 1 minus k square. So d will be equal to square root of d naught square into 1 minus k square. So what is d naught square? If you take out the common square factor, square root, so it becomes d naught into square root of 1 minus k square, where k will be equal to the ratio of internal diameter by the external diameter, which is k is equal to di by d naught. So what is the power transmitted by the shaft? This power transmitted by the shaft will be capital N, which will be equal to 2 pi N into capital T by 60,000 kilowatt. So as both the shafts have the same speed, so therefore NS is equal to NH, and power transmitted by the shaft is directly proportional to the torque transmitted by the shaft. Therefore, power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will be equal to torque transmitted by the hollow shaft divided by the torque transmitted by the solid shaft. So therefore, in terms of the mathematical expression, which is capital NH by capital NS will be equal to capital TH by capital TS. So NH by NS, so that will be equal to what is the torque, that is pi by 16 into d naught to the power of 4 minus di to the power of 4 by d naught into tau H divided by torque transmitted by the solid shaft, that is pi d cube by 16 into tau s. So that is pi by 16 into d cube into tau s. So as the material is same, TH and TS will be equal. So therefore, pi by 16 gets cancels, and taking the d naught to the power of 4 as the common factor into 1 minus di by d naught whole to the power of 4 by d naught into d cube, where tau s will be equal to tau h. Therefore, the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft, that is NH by NS, will be equal to d naught gets cancelled, so d naught cube into 1 minus k to the power of 4 by d cube. The d cube can be written as d into d square. So that will be equal to, substitute the value of d. So d naught cube into 1 minus k to the power of 4 divided by d naught into square root of 1 minus k square into d square into 1 minus k square. So d naught cube gets cancels, that will be equal to 1 minus k to the power of 4 can be written as 1 plus k square into 1 minus k square divided by square root of 1 minus k square into 1 minus k square. So 1 minus k square and 1 minus k square get cancels, and therefore it is left out with 1 plus k square by square root of 1 minus k square, which is always the ratio is greater than 1. So from this we can infer that the power transmitted by the hollow shaft will be more than the power transmitted by the solid shaft when their material, the area of cross section and the speeds are same. So this is how you will be able to compare between the solid shaft, between the hollow shaft and the solid shaft. Thank you.